State whether each sequence is arithmetic, geometric, or neither, and then find a formula for each in terms of n. So, yeah, okay. Do you guys remember what makes it arithmetic or geometric? Arithmetic is if they add the same value over and over. It could be a negative value. And geometric is if they multiply the same value over and over. So number one, 1A, what seems to be the pattern there? Right, they're subtracting 4 or adding -4. So that would be arithmetic, comma, they also wanted a formula for it. Okay. So the way we did it, it's been a long time, but we kind of started back one step. So if they're starting with 10, we need to go back up to 14. And then we're going to subtract what from that? 4 times n, because n being the number of the term. B, I'm going to guess geometric, but I haven't really looked at it. Plus, looks like I was wrong. There is a pattern, +3, +5, +7. That's one way, adding odds. Is that a geometric or arithmetic? No. If you're not adding or multiplying the same value over and over, it's not. Okay, how could we write that as a formula? Ooh, this is kind of a tricky one. Well, yeah, it's a hard one. Not only are they going up by like 3, 5, 7, 9, they're also all, if you subtract 2 from all those, what do you get? 1, 4, 9, 16. What do those numbers have in common? They're squares. So if you do n squared and then +2, that would do it. Yeah. Kind of a weird fact about square numbers. They increase by like an odd number every time, a consecutive odd number. C, -2, 6. What's the pattern on C? Multiplying by -3, so it's a geometric sequence. Okay, so we're going to back up one step. So -2 divided by -3 is 2/3. And we're going to multiply that by -3 n times. So if we plug a 1 in here, we get -3 times 2/3. -3 and 3 cancel out, we get -2. Wait, did we want? Yeah, we want -2 start with this. Okay. Number 2. In the arithmetic sequence, t sub 2 equals 6, and t of 6, t sub 6 equals 16. Okay, we're supposed to find t of 21. Well, it's an arithmetic sequence, is what they told us. So what does that mean? It's supposed to be adding a constant value. So how many terms does it take to get from 2 to 6? 3, 4, 5, 6, 4. Right? So what must they be increasing by 4 times to get from there to there? see, how could I write this? So, this will be the third term, fourth term, fifth term. That'll get us to the sixth term. It's supposed to equal 16. So, if you subtract 6, you get 10. And there's 4 of them in there. 10 divided by 4. Okay, maybe I shouldn't have used N. Probably should use D or something. But anyway, the value that they're adding over and over must be 2.5. So from here to here, it's going up 15 more terms. So it's 15 more of these. It's a mess. Let's see, what was that? 37.5, I think. Yeah. So it's increasing by that much. What was that? 53.5. See if we got it. Yeah, we got it. Yeah, it's a decimal, so I guess that might throw you off, but it's a messy 2.5 increase. Number 3, is it the same kind of idea? Yeah, it is. T sub 3 equals 9. T sub 6, oh, it's a mess, equals 9/8. And we're supposed to find T of 12. T sub 12. Okay, so let me write it this way. Usually we used R for the common ratio, right? So to get the fourth term, we need to multiply by once. Fifth term, sixth term. So you could say 9R cubed equals 9/8. I don't know if we did one exactly like this, but if you divide the 9, you guys know what's going to happen? Yeah, it's like that. R cubed is 1/8. So then what do we do? Cubed root. What's the cubed root of 1/8? 1/2. 1/2 is the common ratio. So to get from the 6th term to the 12th term, that's 6 away. So we're going to have to multiply by 1/2 6 times. That's a mess, isn't it? Times 8. It's like 250. 512. Oh yeah. Okay. Yeah, alright, it's 512 on the bottom. Alright, 4 in a sequence. I write all this down. T sub 1 equals 1, T sub 2 equals 4, T sub n equals T 2 times T sub n minus 1 plus T sub n minus 2. Okay, I don't think there's a quick trick to do this. I think we just gotta kind of start plugging stuff in and see what happens. So the first term I could find is T sub 3. That'll be 2 times t sub, if n is 3, this would be 2. So it's 2 times 4 plus, if if n is 3, this is 1. T of 1 is 1. So this just means the previous term and the previous term, basically is what that means. So it's just 4 and 1. Alright, anyway, that comes out as 9. T sub 4 would be 2 times 9 plus 4. Plus 4. T sub 5. 2 times 22 plus 9. Got 53. T is 6. 2 times 53 plus 22. Getting big. 106 plus 22. 128. Give a recursive definition. Okay, do you guys remember the recursive thingy? It was like t sub n equals 2 times t sub n minus 1. Well, basically it's kind of like this one. You just reference the previous term using t sub n minus 1. Lost my place. Number 5. So we got 1, 5, 21, 85. What is happening here? There's something happening here. Everybody stop. It's almost, you guys see the pattern? Times 4 and plus 1, yeah. So yeah, times 4 would give you like 4, plus 1 would get you up to 5, times 4 is 20, plus 1. Yeah, so it's almost times 4, but it needs a plus 1 to help it out. So remember on recursive, you have to start by defining the first term. You're supposed to anyway. So 4 times the previous term plus 1. Everybody stop. What's that sound? Everybody, what's going on? Okay, number 6. Find the sequence of positive 3-digit integers. This one's kind of weird. Ending in 4. And find an explicit formula. Explicit formula just meant like what we did on number 1, just using n, not t sub n minus 1. So, number 6. Okay, what do they mean? 3-digit integers ending in 4. What would the smallest 3-digit integer be that ends in 4? 104, yeah. So this is not the answer, this is what we need to get though. We need 104, what would the next smallest be? 114, 124, and dot dot dot. I guess since it's only 3 digits, it would end with 994. But they didn't end it, so I guess we don't have to worry about that. Okay, we need explicit formula. Okay. So what's the pattern here? It's not that. It's plus 10. So we just need to make sure it starts off right. So if I just back up one step, kind of like we did on number 1, if I back up one step, it started at 94 plus 10 times n. We never really did the B question on 6, so we'll skip that. That's like how to write it as a series, which is like adding the numbers together. Number 7, find the sum of the first 6 terms of the series. Okay, well, there was a little formula. You could do it, I mean, there's only 6 terms. We could do it without a formula, I guess. 6 is not that many. But there was a little formula we learned. So when we take the test, I'll just put, there's like 3 formulas we used in this chapter. I'll just put them on the board and say what they are. I'm not trying to make, I don't think you guys need to memorize those. 27 minus 9 plus 3. I mean, this is almost the entire thing right here. That's already 4 of them. But what's the pattern? Negative times negative 1/3. So this would be positive 1/3 and then negative 1/9. So we don't really need the formula. We just plug that in. The formula was like, you guys remember this little guy? I think that R was there. No, was it R? 1 minus R right there. Yeah. But it's probably just easier to plug that in. Either way. It's a weird number. Start doing the odds. 8. I do want to go ahead and write this one down. What's the definition of limit in math? I'm going to call it, I'll just write down, the value a series approaches That's how I'm going to define it. The value of series approaches as the number of terms gets larger. It'll never get there, because you can never get to infinity. But it'll be closer and closer and closer and closer. Number 9. Limits. Okay. I feel like we're getting a little bit closer to what we've been doing recently. This might still be last week though. Monday. We didn't do it Monday. Yeah, it's probably last week. Limit as n approaches infinity. Okay, I'm doing a lot of writing for not much. Okay, you guys remember how this works? Talked about it a little bit this week as a reminder, but if the numerator has the larger degree, largest power, it's going to get bigger faster, and it would make the answer infinity. If the denominator has the largest degree, it gets bigger faster, and it would approach 0. But if they're tied, you guys remember what it was? just like that over that. So it's just gonna approach 3/4. What was the other one? Cosine. Yeah. Okay. Do you guys remember what the cosine graph looks like? It goes from -1 to 1, like over and over. So if you put an n in front, what happens to the graph when you put like 2 cosine of x? What does that do to the graph? Yeah. So vertical stretch. So it'd be twice as tall. We call that the amplitude. You guys remember that? The amplitude is doubled, so it looks more like that. Okay, well, what if this number is n and it approaches infinity? What's going to happen? Blow up really fast. So what's the limit? Doesn't exist. B does not have a limit. Most things probably wouldn't, man. Most things probably go to infinity. Okay, so on C, it's 0.59 to the n. Whoops. So if you keep multiplying by a value that's less than 1 over and over, like 1/2 times 1/2 times 1/2 times 1/2, what happens to that value? It gets tiny, tiny, tiny. Does it approach like negative infinity? No, what's it actually approach? 0. Like 1/2 of 1/2 of 1/2 of 1/2. You get like 1 out of a billion eventually, which is almost nothing. So it approaches, the limit approaches 0. Uh, 10, we never did that one, so we'll skip that. 11, that was this week. How are we doing? We're doing all right, We're gonna make it after all. Okay. Interval. Yeah, your guys' favorite, I'm sure. Interval of convergence. This is kind of a mess. So, for something to converge, basically means it has a limit as it approaches infinity. The common ratio, the thing that you multiply by over and over again, has to be less than 1. It's kind of what we were talking about on this C thing. What is the common ratio for this series? Like, what are we multiplying by over and over again? 3x over 2. Well, yeah, because that's a 1. You can kind of just see it right there. But if you do this times 3x over 2, that would give you that. So anyway, it is 3x over 2. So, but also, actually, it's the absolute value. Because if you did -1/2 times -1/2 times -1/2, that also approaches 0. So we need the absolute value of 3x over 2 to be less than 1, which means it needs to be between, absolute value less than, it needs to be between seems like an overreaction. Email?
I don't know, it's just going on.
I was thinking, like, doesn't like the Word documents automatically save and stuff like that? I don't know if emails do. Well, usually can't. Like on the video, usually the only people you can really hear are like the people in these two seats, so maybe you won't hear it. Anyway, oh boy, switch colors. You like reset. And the size isn't right. Oh yeah, whatever. Okay. Smartboard's not that smart. So if you multiply by 2 on all sides and divide by 3, that's the, what do they call it, the interval, what interval? Convergence, interval of convergence. What do you say? Forgot what I was doing. Sum. Okay, there was a little formula for the sum. That little guy of a geometric series. So t sub 1 is just 1, it's the first term. And then you do 1 minus the common ratio, 3x over 2. I don't know. Well, you could manipulate that. We'll just leave it like that. I can never tell if the book's gonna leave it like that or do something with it. I'm peeking and see what, yeah, they did change a little bit. It doesn't really get much simpler than that though. Okay. Number 12. Express each of the following series using sigma. Alright, that's what we're just doing. Oops. There we go. Beautiful. Alright, so can you guys tell what the pattern is on 12A? The denominators are what? Perfect squares, like 3 squared and, oh, wait, that was 3 squared, 5 squared, 7 squared. Instead of 1 squared, 2 squared, 3 squared. So it's the odds squared. Yeah, so we gotta count. Ooh, that's tricky. That's a tricky one. So the top is just 1. How do we get odd numbers to pop out? That's the question. Okay, 1 would be the first odd. How do I get my next odd? How do I turn the 1 into 3? Plus 2. How do I turn it into the next odd of 5? It'd be a plus 4 right here. So what do I need to multiply by right here? Or add right here? 2 ends. That's how you get odds. But the odds need to be squared on the denominator. And there's also something else. You guys know what I missed? There's a negative. The negative needs to be squared too. I guess we could just put a negative right there. Or we could just put it here, put everything squared. No, because then it would be squared. It would just stay negative. Yeah, because it's switching from positive to negative. We could just do this. There's more than one way to handle it, but we could just put a negative in front there, and then just square that. That should do it. pretty way to write it. Does it work? Well, what does our first n value need to be to make this equal to a 1? We need it to be a 0. So I'm going to start with 0. And when we plug in 1, our second term, n equals 1, is supposed to come out as negative 1, 9. Is that going to work? Oh, no, that's not going to work. We need... That would... Where do I need to put that negative at? I'll put this back. To get it to jump from negative to positive, we have to do that. Yeah. Okay, you guys see my problem? The numbers are jumping from positive to negative, so I need it to jump from positive to negative. So we need to keep multiplying by negative 1. So that's how I'm going to fix it. So I put negative 1 to the n on top. Can't do negative 1 squared. The negative squared doesn't help. That just makes it positive. Anyway, that should fix it though. And does it just go forever? What's happening here? No, it only goes to the fifth term, but if we're starting at 0, we need to go to 4. A tricksy one, wasn't it? Let's hope the next one is nicer to us. All right, so on B, I guess the last one, about on time here. What's the pattern? What's easier to me? Looks like they're subtracting 4. And they're starting with a 7. So if we just do 7 minus 4n, with the first n being 0, should that not do it? Yes, it should. And okay, it looks like they're going to 7 terms. So if I'm starting at 0 though,